Far beyond the familiar glow of our sun, nestled within the distant constellation of Leo lies a world that scientists declared humanity's greatest hope, K2-18b. From its vantage point a million miles from Earth, the James Webb Space Telescope, our most powerful eye on the cosmos, pierced through 120 light-years of interstellar void to find it. What it observed was extraordinary. An exoplanet cloaked in a hydrogen-rich atmosphere, exhibiting the distinct chemical signature of dimethyl sulfide, a molecule on Earth exclusively produced by life. This was presented as the definitive proof, the 99.7% certainty that a new Eden, teeming with alien biology, awaited us. But what if the dazzling spectacle of this new Eden is merely a carefully constructed illusion? What if the very certainty proclaimed by our space agencies, the very molecules celebrated as signs of life, are nothing more than a cosmic misdirection, drawing our gaze away from a far more profound and perhaps unsettling truth? The narrative painted for public consumption felt almost too perfect, a beacon of hope in the vast cosmic silence. Yet, behind the polished press releases and carefully curated scientific papers, whispers began to circulate. Unofficial reports, leaked data fragments, and hushed analyses suggested that the James Webb wasn't just detecting alien biology. It had stumbled upon something else entirely, something far older, far more artificial, or even far more dangerous. We will first re-examine the groundbreaking scientific findings that captivated the world, before diving into the shadowy claims of suppressed data, potential techno-signatures, artificial structures, and even a biological threat that has, according to some, rendered any direct mission to this new Eden absolutely forbidden. Prepare to question everything you thought you knew about humanity's place in the universe. If you seek the truth beyond the official narrative, then like this video, subscribe to Terran, prepare yourselves, we begin. On September the 6th, 2023, the scientific community, and indeed the world, was introduced to a revelation that promised to fundamentally reshape humanity's place in the cosmos. The James Webb Space Telescope, a marvel of human ingenuity orbiting at the L2 Lagrange point, had peered across 120 light-years of interstellar space into the constellation Leo. Its powerful infrared gaze settled upon an exoplanet designated K2-18b, a world previously known but now unveiled in startling detail. The official announcement was nothing short of epoch-making, definitive evidence of a potential biosignature, dimethyl sulfide or DMS, within its vibrant atmosphere. The detection wasn't a fleeting anomaly, but a robust signal, painstakingly extracted from the faint starlight filtered through K2-18b's atmospheric layers as it transited its parent star. This method, known as transit spectroscopy, relies on the principle that different molecules absorb specific wavelengths of light, WST, with its exquisitely sensitive near-infrared spectrograph, NIRSpec, and mid-infrared instrument, MIRI, meticulously measured these subtle spectral fingerprints. The K2-18b observations, spanning months and numerous transits, accumulated enough data to reveal not just water vapor, methane, and carbon dioxide, which were compelling in themselves, but also the unmistakable signature of DMS. To understand the profound impact of dimethyl sulfide's discovery, one must first recognize its unique biological significance on Earth. Here, DMS is almost exclusively produced by living organisms. It's the gaseous breath of marine phytoplankton, crucial to the global sulfur cycle, playing a role in cloud formation and climate regulation. Various marine bacteria and certain types of algae also contribute to its atmospheric presence. Crucially, no known geological or non-biological process on our planet generates DMS in quantities comparable to what life produces. Its presence is, for Earth, an unequivocal sign of a flourishing biosphere. Transferring this terrestrial understanding to an exoplanet, the detection of DMS on K2-18b immediately elevated it to a prime candidate for harboring extraterrestrial life. Scientists emphasize that while other potential biosignatures like oxygen or methane can have abiotic origins, DMS possesses no readily identifiable non-biological pathway for its sustained production in an atmosphere. Its persistent presence, detectable across such vast cosmic distances, strongly implied a vast, active and planet-spanning biological system constantly replenishing it against natural atmospheric degradation. This made the K2-18b finding unique, propelling it beyond mere speculation into the realm of near certainty, a level rarely achieved in exoplanet research. K2-18b itself was officially characterized as a Hycean world, a portmanteau of hydrogen and ocean. This super-Earth, roughly 8.6 times the mass of our home planet and about 2.6 times its radius, orbits within the habitable zone of its red dwarf star K2-18. Unlike rocky worlds, Hycean planets possess a thick hydrogen-rich atmosphere enveloping a deep, liquid water ocean. This hydrogen envelope acts as a massive thermal blanket, creating a stable, temperate environment where water can remain liquid across vast swathes of the planet, even potentially extending to its perpetually dark night side due to tidal locking. The climate on K2-18b, as reported, is remarkably stable, with surface temperatures hovering around a balmy 120 degrees Fahrenheit, approximately 49 degrees Celsius. This specific temperature is not just conducive to liquid water, but it falls within a range where many Earth-based extremophils thrive, suggesting that alien life might find it exceptionally hospitable. Furthermore, K2-18, the planet's parent star, is a red dwarf, a type of star known for its incredible longevity, burning steadily for trillions of years. This offers any evolving life on K2-18b an almost limitless timescale to develop and flourish, vastly exceeding the lifespan of our own Sun and Earth's habitable era. The scientific consensus, underpinned by sophisticated statistical analysis, pointed to a 99.7% confidence level that the DMS signal was real and not an artifact or contamination. This level of 3 sigma detection is the benchmark for many groundbreaking discoveries in particle physics and astronomy, signifying that the odds of the observation being a random fluctuation are incredibly small, less than 3 in 10,000. For the first time, humanity had what was presented as undeniable, statistically robust evidence of life beyond Earth, fundamentally altering the trajectory of astrobiology and our cosmic self-perception. Beyond DMS, the presence of methane and carbon dioxide alongside water vapour further bolstered the official narrative of an active biosphere. On Earth, these gases are integral to biological cycles. Their coexistence in K2-18b's atmosphere, particularly in concentrations that suggest chemical disequilibrium, a state where gases that should react and disappear are constantly replenished, reinforced the idea of a thriving planetary metabolism. It was an atmospheric cocktail, a testament to a world where life was not merely surviving but actively shaping its environment on a grand scale, much like our own planet. This confluence of factors, a super-Earth with a hydrogen-rich atmosphere, vast liquid water oceans, a stable red dwarf star, and the undeniable biosignature of DMS with high statistical certainty, led to the rapid designation of K2-18b as New Eden. It shattered preconceived notions that life must resemble Earth-based biology on Earth-like planets, opening up the universe to entirely new categories of habitable worlds. The discovery resonated deeply, offering the profound hope that humanity was not alone, that the universe was teeming with life, and that our cosmic loneliness might finally be drawing to an end. This was the official story, the public truth, a narrative of awe and wonder carefully constructed and presented to a waiting world, poised on the brink of profound revelation. The narrative of K2-18b as a Hycean world presented a captivating vision, a super-Earth swathed in a thick hydrogen atmosphere, beneath which lay a global ocean of liquid water. This model, officially endorsed and widely disseminated, painted a picture of an alien paradise, seemingly more resilient and long-lived than Earth itself. But a closer, more critical look at the underlying assumptions of this Hycean classification and the convenient way it explained away certain spectral data reveals a facade that might be too perfect, too neatly packaged for comfort. Firstly, let's dissect the core concept of a Hycean world. It posits a planet significantly larger than Earth but smaller than Neptune, with a substantial envelope of hydrogen and helium, beneath which atmospheric pressures are immense, leading to a vast, deep ocean. The K2-18b data, with its dominant hydrogen spectral lines and indications of water vapour, methane, and carbon dioxide, fit this model remarkably well. The hydrogen, a much lighter gas than Earth's nitrogen and oxygen, could indeed create a massive blanket, trapping heat efficiently and maintaining stable temperatures across the planet. This atmospheric insulation was crucial for explaining how liquid water could persist, even on the tidally locked night side. This habitable zone facade, however, relies heavily on theoretical modelling. While the James Webb Space Telescope excels at detecting atmospheric constituents, directly confirming the presence of a vast liquid ocean beneath such an opaque high-pressure atmosphere is a monumental challenge. The official reports describe this ocean as a water universe, potentially hundreds of miles deep, a stark contrast to Earth's relatively shallow seas. Yet, these are extrapolations based on atmospheric data and planetary mass, not direct observation. The sheer depth and pressure of such an ocean would create an environment unlike anything we truly comprehend, raising questions about the very definition of life-friendly for organisms that would exist under such conditions. The very stability attributed to K2-18b's hydrogen atmosphere might also be a convenient oversimplification. Red dwarf stars, while long-lived, are notorious for their violent flare activity in their youth, and often continue to exhibit bursts of extreme ultraviolet and X-ray radiation. While official reports highlight K2-18 as a well-behaved red dwarf, this doesn't preclude significant atmospheric stripping events over cosmic timescales. A truly stable Hycean world would need robust mechanisms to replenish atmospheric loss, a detail often glossed over or simply assumed by the vastness of the theoretical hydrogen reservoir in its deep ocean. Furthermore, the concept of a runaway greenhouse effect in reverse, where hydrogen acts as a perfect insulator without leading to Venus-like cooking, is a fascinating but delicate balance. Hydrogen is an excellent greenhouse gas, and its abundance could, in certain models, lead to extremely high temperatures deeper in the atmosphere. The reported 120-degree surface temperature, while ideal for liquid water, requires a very specific atmospheric profile and cloud dynamics to maintain. Any slight variation in composition, stellar flux, or internal heating could drastically alter this equilibrium. The simplicity with which this perfect temperature is presented, despite the planet's alien composition and distant star, raises an eyebrow for those accustomed to the chaotic complexity of real-world planetary climates. The very notion of DMS being solely a biosignature in any environment, let alone one as alien as K2-18b, has faced quiet academic scrutiny, even if not prominently featured in public announcements. While its terrestrial biological origin is undeniable, the universe is vast and capable of producing exotic chemistries we have yet to fully comprehend or observe. Could a hydrogen-rich, high-pressure, water-dominated environment, energized by a red dwarf star, create novel abiotic pathways for DMS production? Some theoretical models, though not mainstream, have explored such possibilities. However, these counter-arguments rarely make it into the accessible public discourse, overshadowed by the compelling narrative of life found. The New Eden moniker itself, while evocative and inspiring, serves to solidify a particular interpretation. An Eden is a place of primordial life, natural and unmarred. This framing steers public perception away from any more complex, perhaps artificial, origins for the atmospheric signals. It simplifies a potentially multifaceted discovery into a singular, easily digestible, and emotionally resonant conclusion. We are not alone. An alien life is fundamentally organic, much like our own, simply adapted to different conditions. This public portrayal of K2-18b, with its perfectly balanced climate, immense hydrogen ocean, and biologically generated atmospheric markers, provided a comforting and inspiring vision of life's ubiquity. It allowed for the awe of discovery without the unsettling implications that might arise from other interpretations of the data. The Hycean world model, while scientifically plausible within certain parameters, functioned as an elegant, almost prepackaged solution to the complex spectral puzzle. It explained away the alienness by making it fundamentally biological, drawing a clear line between the natural processes of a living planet and any other, perhaps more engineered or artificial, phenomena that might otherwise be considered. By presenting K2-18b as a natural, albeit exotic, cradle of life, the official narrative effectively contained the implications. It allowed for excitement and wonder without triggering deeper questions about the nature of that life. Its potential intelligence, or the possibility of its origins being anything other than purely evolutionary. This carefully constructed habitable zone facade, therefore, became more than just a scientific description. It became a narrative barrier, protecting the public from a truth that some might deem too disruptive, too challenging, or even too dangerous to contemplate. The simplicity of life overshadowed the complexity of what kind of life, or indeed what else could it be. The official narrative served as a cosmic filter, allowing only certain truths to pass through, shaping our understanding of this distant world into a palatable, even comforting, new Eden. The figure of 99.7% certainty, proudly announced by scientific bodies regarding the dimethyl sulfide detection on K2-18b, resonated like a cosmic bell tolling the end of our loneliness. In the hallowed halls of science, a confidence level of 3 sigma, meaning only a 0.3% chance of a false positive, is often considered the gold standard for a discovery. It signifies a result so robust that it moves beyond mere statistical fluctuation into the realm of established fact. For the public, this number provided an ironclad assurance. K2-18b was, without a doubt, a world breathing with alien life. Yet, for those who truly understand the nuanced language of scientific evidence, such a pronouncement, while powerful, can also be a strategic instrument of narrative control, capable of both revealing and obscuring truth. In the realm of exoplanet atmospheric characterization, achieving such a high degree of certainty is genuinely a monumental feat of engineering and analysis. The James Webb Space Telescope's instruments, particularly NIRSpec and MIRI, push the boundaries of spectrographic precision. Detecting the faint infrared fingerprint of DMS from 120 light-years away, amidst the overwhelming glare of its parent star, is akin to discerning a whisper in the roar of a jet engine. The light from K2-18b, a mere fraction of the starlight filtering through its atmosphere during transit, carries precious few photons. Each photon is a data point, meticulously collected over multiple observation cycles, spanning months to accumulate enough signal to overcome the pervasive noise inherent in such distant measurements. The process involves sophisticated statistical methodologies, rooted in what's known as Bayesian inference and frequentist approaches. Researchers apply complex algorithms to millions of data points, meticulously modeling potential sources of error, contamination, and astrophysical noise. They simulate countless scenarios, testing whether the observed signal could arise from non-biological processes, instrumental artifacts, or random chance. When these exhaustive tests consistently point to the same conclusion, the undeniable presence of DMS and the probability of it being a fluke drops to 0.3%, then the 3 sigma threshold is met. This is the bedrock upon which major scientific announcements are built, the quantitative guarantee that a discovery is, by all accepted standards, real. However, the very rigor of this statistical certainty can, paradoxically, become a smokescreen. When a scientific body emphatically declares 99.7% certainty for a biosignature, it instills a profound sense of closure and finality in the public imagination. The natural human inclination is to accept this high confidence as an absolute truth, moving on from the question of if to the question of what next. Yet, even at 3 sigma, there remains a minute but non-zero possibility of error. More importantly, statistical certainty regarding the presence of a molecule does not inherently define its origin. The official presentation of K2-18b's DMS detection carefully emphasized its biological origin on Earth, implying a direct parallel. This association, while scientifically justifiable as a leading hypothesis, was presented with a narrative weight that bordered on definitive proof of alien life. The public, understandably captivated by the prospect, largely accepted this interpretation without delving into the subtle, yet critical distinctions between a strong correlation and an absolute causation in an entirely alien environment. The 99.7% certainty applied to the detection of DMS, not necessarily its unambiguously biological origin in all possible cosmic chemistries. Consider the immense complexity of atmospheric chemistry in an environment so profoundly different from Earth. A hydrogen-dominated atmosphere, subjected to the unique radiation environment of a red dwarf star, with a deep, high-pressure water ocean below, could theoretically foster chemical reactions entirely unknown to terrestrial science. While current models struggle to explain significant abiotic DMS production under these conditions, the universe has a notorious habit of defying our limited predictive capabilities. The 0.3% margin of error, though small, leaves a cosmic crack through which unforeseen possibilities could emerge. But this crack is rarely highlighted when the headline is "Life Found." Furthermore, the very act of focusing all public attention on DMS as the biosignature might divert scrutiny from other, perhaps more ambiguous or unsettling data points. If other anomalies or spectral features were present in the James Webb data, signals that didn't neatly fit the biological narrative or that hinted at something more complex, even artificial, the overwhelming statistical confidence in DMS could serve to subtly de-emphasize them. When one extraordinary claim is proven to a high degree of certainty, it naturally dominates the discourse, potentially sidelining equally profound but less easily categorized observations. The unprecedented nature of this certainty, as highlighted in official communications, also sets a powerful precedent. It established K2-18b as a definitive benchmark, a world whose status as a living planet was beyond reproach. This solidifies a specific interpretation, making it significantly harder for dissenting voices or alternative hypotheses, especially those venturing into more speculative territory like technosignatures or artificial manipulation, to gain traction. Challenging a 99.7% certainty, finding requires an extraordinary burden of proof, effectively shutting down avenues of inquiry that stray too far from the established consensus. In essence, the 99.7% certainty, while a testament to scientific prowess, also functions as a powerful rhetorical device. It closes the door on doubt, seals the verdict, and guides public perception toward a singular, comforting truth. Alien life is out there, and it's probably just like ours, but adapted. It's a truth that satisfies, inspires, and, most importantly, maintains a predictable narrative arc. The question then becomes, was this high-confidence figure a purely objective scientific declaration, or was it also a strategic maneuver to control the narrative surrounding a discovery whose full implications might be far too profound and perhaps even disruptive for an unprepared world? The unnerving precision of that 99.7% doesn't just confirm a detection, it confirms a story, a specific chapter in humanity's encounter with the cosmos, and it leaves little room for the unsettling possibility that K2-18b might be far more than just a new Eden. Despite the official narrative's confident pronouncements, the silence from certain corners of the astrophysics community following the K2-18b announcement was telling. Not outright contradiction, but a subtle undercurrent of unease, a murmur of "what about?" that hinted at data points deliberately downplayed or interpretations subtly nudged. It is within these digital shadows, in the hushed conversations of forums not meant for public consumption, and in the leaked analytical reports that never saw official publication, that the first whispers of discrepancy began to solidify into troubling questions. The James Webb Space Telescope operates by collecting incredibly faint signals across vast distances. Its raw data streams are colossal, often containing information far richer and more complex than what is initially extracted and highlighted in public releases. While the detection of dimethyl sulfide was undeniably significant, some internal analyses allegedly pointed to additional unexplained features within the infrared spectrum of K2-18b. These were not immediately dismissed as noise, but rather categorized as anomalous data points, or unresolved spectral features, scientific euphemisms that can often precede a paradigm shift, or, as some speculate, a deliberate suppression. Imagine, for instance, a spectral line that was unusually narrow or sharp, defying the expected broadened profiles of gases in a natural planetary atmosphere. Natural atmospheric gases, subject to thermal motion and pressure broadening, tend to produce spectral features with a certain natural width. An unnaturally sharp or precise absorption or emission line could suggest a gas existing in a highly controlled, non-equilibrium state, or even an interaction with light in a way not typical of pure thermal processes. Such a finding, if robust, would immediately raise questions far beyond simple biology. These were the kinds of discrepancies, according to purported leaks, that appeared in certain datasets but were subsequently attributed to instrumental artifacts or complex atmospheric dynamics requiring further modelling in internal communications without public mention. Another unsettling pattern allegedly observed involved unexplained light variations during K2-18b's transits. While the primary mission was to analyse atmospheric composition, detailed photometric data from the transits also recorded minute fluctuations in the starlight. Some of these variations were reportedly inconsistent with typical planetary transits. Instead of a smooth, uniform dip as the planet passed in front of its star, certain transits showed momentary sharp dips or even spikes in brightness that lasted for fractions of a second. These micro-lensing-like events, or transient luminosity enhancements, defied easy explanation by a homogeneous planetary disk. While natural phenomena like stellar flares or sunspots could be invoked, the consistency and pattern of these specific anomalies in certain observation windows hinted at something far more deliberate, almost systematic. Furthermore, there were whispers regarding the distribution of the detected gases within K2-18b's atmosphere. While the official narrative highlighted the planet-wide presence of DMS, methane, and water, certain leaked models reportedly indicated an uneven, almost layered distribution of these compounds that wasn't entirely consistent with global atmospheric circulation models for a tidally locked world. For example, some spectral signatures were allegedly much stronger or weaker in specific orbital phases, suggesting localized hotspots or cold spots of chemical activity that couldn't be explained by simple atmospheric mixing and energy redistribution. These localized anomalies, particularly if they appeared with an unnatural regularity, would challenge the very notion of a uniform, naturally evolving Hesian biosphere. One particularly intriguing claim involved a subtle, yet persistent asymmetry in the planet's atmospheric absorption profile. When light passed through the leading edge of K2-18b's atmosphere versus the trailing edge, slight but statistically significant differences were allegedly detected in certain spectral bands. Natural atmospheric dynamics, like strong winds or temperature gradients, can cause some asymmetry. However, the reported asymmetry was said to be far more pronounced in specific complex molecular bands, hinting at processes that were not merely natural, but potentially engineered. An atmosphere manipulated on a global scale could exhibit such localized non-equilibrium states, maintaining specific chemical gradients that serve a purpose beyond mere biological respiration. These glitches in the matrix of the K2-18b data were not necessarily definitive proof of anything, but their very existence, and the alleged efforts to contextualize them strictly within known astrophysical or biological frameworks, raised red flags for those privy to the full spectrum of observations. Why were these anomalies not thoroughly investigated and publicly addressed? Why was the overwhelming focus placed solely on the DMS biosignature, almost to the exclusion of other, more perplexing data points? The official explanations, while plausible on their own, collectively seem to oversimplify a truly complex dataset, forcing it into a preconceived framework that championed life as we know it, over the unsettling possibilities of life as we don't know it, or even phenomena we can't explain naturally. The undercurrent of these discrepancies, these unexplained whispers in the data, began to coalesce into a powerful counter-narrative. It was a narrative that suggested the James Webb Space Telescope had, perhaps inadvertently, captured far more than just a simple biosignature. It had, according to these leaks, captured subtle but persistent evidence that K2-18b was not just a biological wonder, but a cosmic puzzle box, whose deeper layers contained information that challenged the very foundation of how we search for and interpret alien life. The anomalies were not errors, they were clues, pointing to a story far grander and more intricate than the one NASA had chosen to tell. The official narrative, shimmering with the promise of simple, thriving biology, stood in stark contrast to the unsettling implications whispered in the scientific undercurrents. If the subtle glitches and persistent anomalies in K2-18b's data were not mere observational quirks or complex natural processes, then a far more revolutionary possibility emerges: the detection of technosignatures. This term, coined by the SETI community, refers to any observable manifestation of technology produced by an extraterrestrial intelligence. It's the search for the universal fingerprints of engineering rather than just the breath of life. The concept of a technosignature moves beyond basic biochemistry, venturing into the realm of civilization. It asks not just, is there life, but is there intelligence that has altered its environment in ways detectable across cosmic distances? While the initial detection of dimethyl sulfide pointed to a biosphere, the alleged discrepancies within the James Webb data, if re-evaluated through a different lens, could very well hint at industrial-scale processes, planetary engineering, or even advanced communication signals. Consider the notion of unnatural atmospheric compounds beyond dimethyl sulfide. While DMS is a biological marker on Earth, what if the JWST data contained faint, yet persistent spectral lines of highly stable synthetic molecules? Imagine gases that possess no known natural astrophysical or biological origin, molecules designed for a specific purpose by a sophisticated civilization. These could be industrial byproducts of advanced energy generation, refrigerants for planetary climate control, or even specific chemicals used in terraforming or atmospheric manipulation. Such designer molecules, if found, would be unequivocal proof of technology. The leaks suggest that certain unidentified spectral lines, initially dismissed as noise or poorly understood chemical interactions within K2-18b's alien atmosphere, might actually fit the profiles of such synthetic compounds, especially when cross-referenced with theoretical models of exoplanetary industrial output. Furthermore, the alleged unexplained light variations during K2-18b's transits take on a new, profound meaning when viewed through the lens of technosignatures, a series of perfectly timed minute fluctuations in starlight, particularly if they appeared with an algorithmic regularity or defied natural astrophysical explanations, could be indicative of orbital megastructures. Dyson spheres, or more likely partial Dyson swarms or stellar engines, are theoretical constructs designed by advanced civilizations to harness immense amounts of stellar energy. Even incomplete versions such as orbiting habitats or solar collectors could cast faint, non-uniform shadows during transits, creating light curves that deviate from a simple, spherical planet. The alleged transient luminosity enhancements could even be interpreted as controlled emissions of light or energy from such structures, perhaps for propulsion or communication, momentarily brightening specific areas during transit. Another compelling technosignature hypothesis arises from the apparent unnatural stability of K2-18b's climate and atmospheric composition over cosmic timescales. While the red dwarf star provides longevity, a dynamically stable atmosphere in such an extreme environment, resistant to stellar flares and atmospheric escape for eons, might suggest more than just fortunate natural processes. Could the thick hydrogen envelope itself be actively managed? Perhaps giant atmospheric scrubbers or vast interconnected geoengineering systems are at play, maintaining the delicate balance that allows life or civilization to thrive. Such planetary-scale engineering would leave subtle but detectable chemical byproducts or energy signatures in the atmosphere, precisely the kind of anomalies allegedly suppressed in the public data. The very distribution of dimethyl sulfide, if indeed it is biological, also offers a technosignature angle. If a civilization actively cultivates a planetary biosphere for resources or terraforming, it might optimize the production of certain biological markers. An unusually high concentration of DMS, far beyond what might be expected from spontaneous evolution, or a non-uniform distribution that correlates with specific geographic or orbital features, could imply intelligent oversight. It would be a cultivated Eden, rather than a wild one. The alleged localized hotspots of chemical activity in the leaked data, if precisely patterned, could be interpreted as controlled biospheres, managed ecological zones, or even waste heat signatures from subsurface installations. The asymmetry in atmospheric absorption also becomes deeply significant. If a civilization is conducting large-scale atmospheric manipulation, such as injecting specific chemicals or gases into different regions, this could lead to non-uniform absorption profiles. Imagine a vast industrial complex or a climate control network that preferentially introduces or removes certain molecules from one side of the planet, creating a chemical gradient detectable from space. Such a deliberate disequilibrium, maintained over vast periods, would be a hallmark of advanced technological intervention. The implications of even considering a technosignature for K2-18b are staggering. It transforms the discussion from mere alien pond scum to an encounter with potential peers, or perhaps ancient architects. It means humanity isn't just looking at a world with life, but a world shaped by intelligence. This shift in perspective fundamentally changes the stakes. A simple biosignature elicits wonder. A technosignature demands a re-evaluation of our place in the cosmic hierarchy and forces us to consider the implications of contact with a civilization potentially billions of years older and infinitely more advanced than our own. The alleged suppression of these technosignature hypotheses, the swift channeling of public attention towards a purely biological interpretation, speaks volumes. It suggests a deliberate strategy to control the narrative, perhaps out of a genuine fear of public panic or a desire to retain exclusive control over potentially world-shattering information. For if K2-18b isn't just a natural haven for simple life, but a monument to an alien civilization, then the New Eden becomes something far more complex. A cosmic artifact, a silent sentinel, or even a technological trap, and the James Webb, our instrument of revelation, may have accidentally opened a door to a truth that some believe should have remained shut. If the technosignature hypothesis pushes the boundaries of our imagination, then the notion of traces of artificial structures on K2-18b shatters them entirely. This isn't merely about engineered atmospheres or energy collection, it's about solid, physical constructs, vast enough to register across 120 light-years of cosmic distance, hinting at a presence that reshapes the very planet itself. The James Webb Space Telescope, while not designed for direct imaging of exoplanet surfaces, possesses an exquisite sensitivity that, under specific conditions, could detect the subtle gravitational or luminous impact of truly colossal artificial mega-engineering. Consider the immense mass of K2-18b, a super-Earth nearly 9 times that of our homeworld. Its sheer gravitational pull would typically dictate a relatively uniform, albeit deep, atmospheric and oceanic structure. Yet, some analyses, purportedly from leaked datasets, pointed to unexplained gravitational anomalies detected during K2-18b's precise orbital dance. These were not the gentle nudges of another distant planet, but subtle, recurring shifts in the planet's gravitational signature as it transited, as if immense, unevenly distributed masses were embedded within or on its surface. While seismic activity or unusual geological formations could offer natural explanations, the alleged regularity and distinct patterns of these microgravitational distortions hinted at structures too orderly for chaotic natural processes. Such patterns might suggest massive suboceanic cities, continent-sized platforms, or even planetary-scale industrial complexes whose sheer density and geometry exerted a measurable, non-uniform gravitational influence. The concept of surface features too ordered for natural geology is another area of intense speculation within these covert circles. While K2-18b is obscured by a dense atmosphere and deep ocean, certain sophisticated spectral analyses, pushing the limits of JWST's capabilities, can infer characteristics of the underlying surface. For instance, the way specific wavelengths of light interact with the planet's lower atmosphere and surface can reveal hints of topography and material composition. Allegedly, some of these deep-layer spectral profiles exhibited absorption or reflection patterns that were too uniform, too linear, or too geometrically precise to be easily explained by natural geological processes like volcanic activity, tectonic shifts, or oceanic currents. Picture immense, straight lines stretching across vast distances, or perfectly symmetrical arrangements of features that defy the fractal chaos of nature. These could be interpreted as the hallmarks of ancient, long-abandoned cities, vast agricultural complexes under the ocean, or even the remnants of a planetary-scale grid system. The unexplained light variations during transits, previously discussed as potential technosignatures, take on a new dimension when considering artificial structures. If K2-18b hosts gargantuan constructs, whether floating cities above its hydrogen sea or immense suboceanic habitats, these could subtly alter the planet's silhouette against its star. A natural planet presents a relatively smooth, consistent profile. However, if immense, irregularly shaped, or highly reflective structures punctuated its upper atmosphere or orbited in close proximity, they could create complex, non-uniform light curves. Imagine the transient glint of a massive orbital mirror or the jagged shadow of a vast space station. These microvariations, if they appeared with an intelligent periodicity or an artificial signature, would be incredibly difficult to explain naturally. Furthermore, the very stability of K2-18b's supposed perfect temperature could be maintained not just by atmospheric composition, but by active, physical intervention. If the planet truly harbours an advanced civilization, they might have deployed planetary-scale climate control systems. These could manifest as colossal orbital shades or reflectors, diverting stellar energy to maintain thermal equilibrium, or, conversely, vast energy-generating facilities on or beneath the surface, radiating waste heat that contributes to the overall warmth. These immense structures, even if partially obscured, could leave a faint thermal signature or cast a subtle light-blocking effect detectable by JWST's infrared eyes, adding to the data anomalies that fueled the artificial structure's claims. Even the DMS itself, if truly biological, could be part of an engineered ecosystem. What if the new Eden is not a pristine, naturally evolving biosphere, but a vast, meticulously cultivated farm? An advanced civilization might genetically engineer specific microorganisms to produce DMS at optimized levels, perhaps as a form of atmospheric terraforming, resource production, or even waste processing. Such a controlled, planet-wide biological system would require immense infrastructure and management, the physical traces of which might be subtly detectable through gravitational anomalies or unusual spectral uniformity in specific regions. The reluctance to openly discuss such possibilities within official channels, despite the alleged presence of supporting anomalous data, strongly suggests a deliberate choice. The implications of discovering active, physical megastructures on an exoplanet are far more profound and immediate than the detection of simple alien microbes. It transforms the cosmic "we are not alone" into "they are here and they are powerful." The existence of such structures would indicate a civilization not merely intelligent, but ancient, enduring, and capable of engineering worlds on a scale we can barely fathom. Such a revelation would trigger global societal upheaval, challenging every existing framework of science, religion, and philosophy. The very notion of humanity's uniqueness, its place at the apex of intelligence, would be shattered. Perhaps this is why the New Eden narrative, with its focus on benign, natural biology, was so meticulously crafted. It's a truth that's digestible, inspiring, and non-threatening. But if the leaks are true, K2-18b is not just a biological curiosity. It's a monumental achievement of alien engineering, a silent testament to a civilization that has transcended the natural limits of its world. And perhaps that truth is deemed too destabilizing, too monumental, for humanity to confront head-on, at least not yet. The artificial structures, if they exist, might be the most closely guarded secret of K2-18b, the resounding cheer that greeted the K2-18b announcement, the pronouncements of New Eden, and the enthusiastic projections of future astrobiological research all seem to lead to a single, obvious next step: send a probe. If K2-18b is indeed a planet teeming with life, a potentially more habitable world than Earth itself, then surely the most logical and urgent course of action would be to initiate the planning for an interstellar mission. Yet, the striking absence of any such aggressive proposals, the pronounced silence regarding even conceptual mission architectures to this Eden, serves as one of the most glaring inconsistencies in the official narrative. It begs the question, why no mission to Eden? Interstellar travel remains a monumental challenge, pushing the very limits of our engineering and theoretical physics. A journey to K2-18b, 120 light-years away, would take humanity's fastest current spacecraft, like the New Horizons probe, millions of years. Even with breakthroughs in propulsion technology, such as fusion drives or hypothetical warp speed equivalents, a manned mission is generations, if not centuries, away. However, robotic probes capable of making this journey, perhaps travelling at a fraction of the speed of light, are within the realm of future possibility. Projects like Breakthrough Starshot aim to send tiny probes to Alpha Centauri within decades, albeit at very high fractions of light speed. A similar, larger-scale endeavour to K2-18b, even if it took centuries, would be the natural scientific imperative for such a profound discovery. Yet, there has been no public call for an accelerated interstellar probe development program specifically targeting K2-18b. No grand challenge has been issued to the global scientific community. Instead, the focus remains on further remote observation with increasingly powerful telescopes. While continued remote sensing is crucial, it hardly matches the existential significance attributed to the discovery of alien life. If we are 99.7% certain life exists there, the scientific urgency to get a closer look should be overwhelming, even if the timeline is vast. The lack of this urgency, the conspicuous absence of even long-term conceptual mission planning, generates a potent vacuum for speculation. One might argue that the technical hurdles are simply too great, that any mission is too far in the future to warrant public discussion now. But this is a disingenuous argument. The history of space exploration is filled with ambitious, multi-decade projects that began with conceptual studies and public engagement long before the technology was fully mature. From Project Apollo to the James Webb itself, humanity has always dared to dream and plan decades, even a century, into the future for objectives of such monumental importance. The silence surrounding a mission to K2-18b, a world now officially declared to be breathing with life, is therefore not just practical, it feels deliberate. This absence of mission planning fuels the theory that a deliberate cover-up is underway. If K2-18b truly harbours a benign biosphere, an Eden awaiting exploration, why the hesitation? Why the lack of a concerted, global effort to reach it, even robotically? The answer, according to the leaks, lies in the nature of the true discovery. What if the James Webb data, beyond the sanitized public releases, revealed something that made a mission not merely difficult but prohibited? This is where the notion of K2-18b as a forbidden zone begins to take root. If the alleged techno-signatures or artificial structures are real, then a direct mission would cease to be a simple scientific endeavour and transform into a complex, potentially perilous act of first contact, approaching a world demonstrably shaped by an advanced civilization without understanding their intentions, their capabilities, or their territorial claims would be an act of profound irresponsibility, perhaps even an act of war. The silence on missions in this context is not due to technical impossibility, but to extreme caution or even fear. Conversely, if the biological threat theory holds true, a close encounter becomes an even more immediate danger. What if the life on K2-18b, while thriving, is based on a biochemistry so profoundly alien that it poses an existential risk to Earth life, or even human biology? Unknown pathogens, hyper-aggressive extremophiles, or a biosphere that actively processes elements in ways toxic to us could render any direct interaction catastrophic. A mission, under such circumstances, would be an act of biological suicide, warranting the most stringent quarantine protocols imaginable. Protocols that begin with a global moratorium on even discussing a mission. The public narrative of a benign Eden, therefore, acts as a necessary shield, preventing panic while discreetly enacting a policy of extreme non-intervention. The official narrative presents a comforting, inspiring vision of K2-18b, a testament to life's abundance. But the absence of a mission plan is a powerful counterindicator. It is a strategic decision, cloaked in the practicalities of interstellar travel, yet hinting at a deeper, more unsettling truth. The very world hailed as humanity's greatest discovery, the New Eden, remains untouchable, almost as if it's under a cosmic embargo. This deliberate lack of follow-up beyond passive observation suggests that the information held by agencies like NASA extends far beyond a simple biosignature. It implies a calculated assessment of risk, a strategic decision to maintain distance from something truly extraordinary and potentially dangerous. The public is offered a tantalizing glimpse of a living world, but denied the journey to its shores. This discrepancy between the monumental nature of the discovery and the subdued response to it is, for many, the clearest indicator that what is truly known about K2-18b is far more profound and far more concerning than the story we have been told. The New Eden is not for us to visit, and the reasons why are allegedly hidden behind layers of carefully managed information. If the anomalies in the data and the perplexing lack of mission planning weren't enough to fuel suspicion, the most unsettling theories surrounding K2-18b delve into the chilling possibility of a profound biological threat. This isn't about mere alien bacteria, it's about life so fundamentally different, so existentially incompatible with our own, that its very presence, even 120 light-years away, warrants extreme measures of secrecy and isolation. The New Eden, then transforms into a cosmic Pandora's box, whose contents are too dangerous to reveal, let alone approach. Imagine a biosphere evolved under conditions so alien, a hydrogen-rich atmosphere, crushing pressures, and a deep solvated ocean, that its fundamental biochemistry operates on principles antithetical to terrestrial life. On Earth, our biology is built on a fragile carbon-water framework, susceptible to extreme temperatures, radiation, and incompatible chemistries. What if K2-18b's dominant life forms thrive on metabolic pathways that are not just different, but actively destructive to carbon-based organic matter? Consider hyperacidic or hyperalkaline internal environments, organisms that utilize exotic heavy metals as structural components, or even those that metabolize radiation directly, evolving resistance mechanisms that make them hypervirulent to anything less robust. The dimethyl sulfide, DMS, detected, while a biosignature on Earth, could take on a sinister new meaning in this context. What if the DMS, in K2-18b's environment, is not merely a benign metabolic byproduct, but a signaling molecule for a planet-wide collective intelligence, or perhaps a potent airborne spore? The sheer abundance of DMS, reportedly orders of magnitude higher than Earth's, could indicate an ecological dominance beyond our comprehension, a single, vast, interconnected superorganism that governs the entire world. Such a collective entity, if sentient or even instinctively defensive, might perceive any external interference as a threat, triggering an unknown, but potentially devastating, response. Furthermore, the concept of a biological threat encompasses more than just microscopic pathogens. What if the life forms on K2-18b, driven by eons of evolution under conditions of unlimited time around a red dwarf star, have reached a level of complexity and aggression that makes them inherently dangerous? We are accustomed to thinking of alien life in terms of simple organisms or benevolent intelligences, but the universe is also capable of producing hyper-competitive predatory biospheres. Imagine an ecosystem where life forms are designed by evolution to consume any foreign organic matter, or to incorporate new genetic material into their own, rapidly adapting and propagating. A probing mission, even robotic, could inadvertently introduce a vector for such a threat, bringing back not just samples, but an existential danger. The alleged anomalies in K2-18b's atmospheric data could also be reinterpreted through this chilling lens. An unusually strong and persistent presence of highly reactive toxic gases beyond what biological processes usually produce could indicate an actively defended biosphere. If certain molecular compounds detected are potent biocides to Earth life, or if they represent the atmospheric waste products of a hyper-efficient, ecologically dominant species that consumes and processes its environment with terrifying efficiency, then the New Eden becomes a world actively hostile to our existence. The unexplained light variations could even be interpreted as warning signals, or localized atmospheric disruptions designed to repel potential intruders. The silence of the agencies regarding missions to K2-18b takes on an even more profound significance under the biological threat hypothesis. It's not just caution, it's a global quarantine, a cosmic exclusion zone. The absolute imperative would be to prevent any form of contact, accidental or deliberate, that could compromise Earth's biosphere. This would necessitate not just secrecy, but a concerted international effort to suppress any information that might inspire rogue missions or unauthorized probes. The 99.7% certainty of DMS, a comforting narrative of life, becomes a double-edged sword. It proves life exists, but if that life is a threat, then the truth must be carefully managed to prevent panic and ensure planetary security. Consider the ethical dilemmas involved. If NASA, or a clandestine consortium of global agencies, genuinely possesses data suggesting an existential biological threat from K2-18b, how would they communicate that to the public? A global panic, a collapse of societal order, an unimaginable fear of the unknown. These would be the immediate consequences. The strategic decision to present K2-18b as a benign New Eden, while quietly enacting a forbidden mission protocol, would become a painful but perhaps necessary measure to protect humanity from itself, and from the potentially catastrophic implications of the truth. This theory aligns with the profound lack of follow-up observations that would clarify the nature of any advanced intelligence or artificial structures. If the threat is biological, then further prying, further attempts to analyze it in detail, might only increase the risk of accidental exposure or provoke an unwanted response. The safest course of action is simply to observe from a distance, categorize it as life, and prevent any closer interaction. The psychological impact of discovering a truly hostile, planet-spanning alien biosphere would be immense, far greater than finding benign microbes. It would shatter our romanticized notions of extraterrestrial life and force a reckoning with the universe's indifference, or even its active hostility. This could be why the truth about K2-18b, according to these whispers, is so fiercely guarded. The New Eden might be a biological marvel, but it could also be a cosmic warning, a testament to evolution's darker paths, a world where life has become an insurmountable planetary-scale threat that makes any mission there not just ill-advised, but absolutely forbidden. The implications are chilling. We've found life, yes, but it might be the kind of life we must never ever disturb. The convergence of anomalous data, the curious absence of mission planning, and the unsettling theories of technosignatures or biological threats inevitably leads to the most provocative accusation that NASA, and by extension, a cabal of international space agencies, is actively engaged in controlling the narrative. This isn't mere scientific caution, it's a deliberate act of obfuscation, a calculated public relations strategy designed to manage the profound, potentially destabilizing truth about K2-18b. The question is not if they're doing it, but why and how they're orchestrating this cosmic deception. The motivation for suppressing information of such magnitude stems from a complex interplay of factors. Foremost among them is the potential for global panic. Humanity has long fantasized about alien contact, but the reality of an advanced civilization or a hostile biosphere could trigger widespread societal breakdown. Economic markets could crash, religious doctrines could be shattered, and geopolitical stability could erode as humanity grapples with its suddenly diminished cosmic significance or an existential threat. Agencies like NASA, often operating under immense public scrutiny and governmental control, are acutely aware of these societal fragilities. Presenting a manageable, inspiring narrative of simple life on New Eden provides a controlled release of awe without unleashing uncontrollable fear or chaos. Another powerful motivator is the desire to preserve control over potentially world-altering knowledge. The first confirmed discovery of intelligent alien life, or even a planet-wide biological threat, would fundamentally shift the balance of power on Earth. The entity that controls this information and the subsequent response would wield unprecedented influence. If K2-18b holds secrets of advanced technology, or even a pathway to interstellar travel gleaned from its advanced inhabitants, then the strategic imperative would be to keep such information within a tightly controlled circle, preventing it from falling into the wrong hands or being exploited by rival nations. The New Eden narrative in this context buys time, allowing for internal deliberation and strategic planning without public interference. The method of controlling this narrative is subtle but effective, a masterpiece of scientific public relations. It begins with the overwhelming emphasis on specific, easily digestible findings, like the 99.7% certainty of dimethyl sulfide. This data point, while scientifically robust, serves as a powerful anchor, solidifying a particular interpretation and deflecting attention from less convenient facts. Any anomalous spectral lines, unusual light curves, or gravitational distortions are then expertly contextualized or attributed to known phenomena, instrumental error, stellar flares, or complex atmospheric dynamics, before they can gain traction as evidence of something more profound. Furthermore, the language employed in official announcements is meticulously crafted. Words like potential biosignature and habitable world are technically accurate but carry a strong emotional charge, fostering a sense of wonder that overshadows any lingering scientific ambiguities. The framing of K2-18b as New Eden is a masterstroke, evoking a powerful, comforting archetype of paradise, inherently benign and inviting. This carefully constructed rhetoric shapes public perception, making it difficult for alternative, more unsettling interpretations to penetrate the collective consciousness. The suppression isn't necessarily about outright lying, but about selective disclosure. It's about presenting a portion of the truth, the portion that is deemed safe and inspiring, while holding back the rest. This strategy relies on the public's trust in scientific institutions and the sheer complexity of the data, which makes independent verification by laypersons virtually impossible. The scientific community itself, driven by the intense competition for publications and funding, also tends to favour clean discoveries that fit within established paradigms, making it easier to filter out the messy data that might hint at more radical truths. The alleged leaks, however, represent a breach in this meticulously constructed narrative wall. These are not necessarily official documents, but fragments of internal analyses, informal communications, and the quiet dissent of scientists who feel the full truth is being withheld. They are the digital breadcrumbs that allow for a re-evaluation of the official story. Providing context for the subtle inconsistencies and unexplained phenomena, these leaks challenge the idea that scientific discovery is a purely transparent process, exposing the human and political dimensions that inevitably influence how profound cosmic truths are presented or withheld from the world. For those who adhere to the NASA is hiding something theory, the control of the K2-18b narrative is a test case, a demonstration of how governments and powerful institutions manage information that could reshape civilization. It suggests a strategic, long-term plan to incrementally introduce humanity to the realities of a living universe, starting with the least threatening revelations and slowly building towards more profound and potentially more dangerous truths. The New Eden then becomes a necessary stepping stone, a carefully managed illusion designed to prepare us, or perhaps to simply keep us docile, until the powers that be decide we are ready for the full, unvarnished truth of K2-18b. This orchestrated control of information highlights a fundamental tension between humanity's insatiable curiosity for cosmic truth and the perceived need for global stability. The official K2-18b narrative, therefore, might be less about pure scientific fact and more about a carefully calibrated experiment in public psychology, a soft unveiling of the alien designed to prevent mass hysteria. The question remains, how much longer can they maintain this delicate balance, and what happens when the hidden truths finally break free, not merely being discovered, it is being managed. We embarked on this journey with the comforting image of K2-18b as a new Eden, a world breathing simple organic life, confirmed by cutting-edge science. But by digging deeper, beyond the official announcements, into the alleged leaks and the unsettling analysis, a vastly different, more complex and potentially terrifying truth begins to coalesce. The K2-18b that NASA might be hiding is not merely a biological marvel, it is a cosmic Pandora's box, a world shrouded in secrets that challenge our very understanding of life, intelligence, and humanity's place in the galactic order. Let us synthesize these covert whispers and suppressed data points into a coherent, albeit speculative, vision of the real K2-18b. It starts with the very dimethyl sulfide detection. While publicly hailed as an unambiguous biosignature, the alleged unnatural abundance or peculiar distribution of DMS could point to a biosphere not naturally evolved, but deliberately cultivated on an immense planetary scale. Imagine a vast engineered ecosystem, meticulously managed to produce specific atmospheric compounds for reasons we can only guess at, perhaps atmospheric stabilization, resource extraction, or even as a complex form of global communication. This isn't just life, it's managed life, implying an intelligence behind its orchestration. Then there are the subtle, yet persistent anomalies in the light curves and spectral data, the reported sharp, narrow spectral lines that defy natural broadening, or the transient luminosity enhancements during transits. These aren't just instrumental glitches. They could be interpreted as the direct energetic output of advanced technology. Think of colossal energy harvesting arrays, perhaps akin to a partial Dyson swarm, orbiting K2-18b and drawing power from its red dwarf sun. Such structures, even if partially obscured by the dense hydrogen atmosphere, would subtly alter the planet's light signature in ways too precise, too geometric for natural explanations. The very brightness spikes could be the brief, powerful flashes of exotic propulsion systems or directed energy transmissions. And what of the gravitational anomalies and geometrically ordered surface features allegedly inferred from deeper analyses? If the Hysian model is indeed a facade, then beneath the vast deep oceans and thick atmosphere, there might lie colossal artificial structures, sub-oceanic cities of immense scale, or even planetary engineering constructs that reshape the planet's very mass distribution. These wouldn't be mere geological formations. They would be the monumental fingerprints of a civilization that terraformed its world, building an entire hidden infrastructure beneath the protective, opaque atmospheric veil. Such a civilization could be ancient, having built its marvels eons ago, perhaps lying dormant or existing in a state of suspended animation, their creations still subtly influencing the planet's observable characteristics. The unnatural atmospheric stability over vast timescales, often attributed to the red dwarf's longevity, could also be a product of deliberate maintenance. This isn't just a world where life adapted, it's a world protected and optimized by its inhabitants. Imagine a sophisticated climate control system, a global network of atmospheric processors and deflectors, constantly battling stellar flares and atmospheric escape, ensuring an eternally habitable environment for its creators. Such a system would leave a distinctive, non-random imprint on the atmospheric chemistry and dynamics, a telltale sign of intelligent stewardship. But then, the most unsettling possibility emerges: the biological threat. What if this managed Eden, this planet of engineered life and hidden structures, is not benign? What if the ruling intelligence, or the dominant biosphere itself, perceives external contact as an existential risk? The K2-18b revealed in the leaks might be a quarantined world, a cosmic exclusion zone. The advanced life forms or technologies there could be actively producing biocidal compounds to deter intruders, or radiating unknown forms of energy that are harmful to foreign biology. The Forbidden Mission isn't merely a precaution against a misunderstanding, it's a critical defense against a potent, possibly hyper-aggressive alien entity or a self-aware planetary biosphere that views our approach as an invasion. The real K2-18b, therefore, is a far cry from the comforting New Eden. It is a world potentially populated by an advanced, perhaps ancient civilization that has mastered planetary engineering and potentially biological manipulation on an unimaginable scale. Or it is a world dominated by a form of life so profoundly alien and potentially dangerous that it represents an existential threat to Earth. Perhaps it is both, an ancient civilization that long ago engineered its world, only to fall victim to or be transformed by the very biological systems it sought to control. This hidden K2-18b is a profound paradox, a beacon of life, yet a realm of extreme caution. It is a testament to the universe's boundless creativity, yet a chilling reminder of its potential dangers. Unveiling this deeper truth would not merely be a scientific discovery, it would be a societal earthquake, forcing humanity to confront its own vulnerability, its cosmic naivete, and the profound ethical responsibilities of encountering such advanced or dangerous realities. The official narrative serves as a protective filter, shielding us from the unsettling possibilities, the deep implications that could shatter global confidence and ignite unmanageable fears. The New Eden is a story, a necessary illusion perhaps, to keep the lid on a cosmic Pandora's box that, if truly opened, could change humanity forever. We began this profound cosmic exploration with a vision steeped in celestial promise. K2-18b, shimmering as the proclaimed New Eden, brought into sharp focus by the unprecedented capabilities of the James Webb Space Telescope. The official pronouncements, broadcast with an air of scientific triumph, painted a vivid, almost ethereal picture, a super-Earth, bathed in the distant light of its red dwarf star, K2-18. Its dense, hydrogen-rich atmosphere was reported to be pulsing with the unequivocal signature of dimethyl sulfide, a molecule that, on our verdant homeworld, is a definitive byproduct of thriving biological processes. This was presented not merely as a scientific observation, but as the long-awaited culmination of humanity's most ancient longing, the irrefutable, statistically robust evidence, ringing with 99.7% confidence, that our species is far from alone in the silent expanse of the cosmos. It was a truth carefully curated to inspire boundless wonder, to dramatically expand our intellectual and spiritual horizons, and to finally, definitively, put an end to the profound ache of our cosmic loneliness. Yet, as our journey veered beyond the meticulously constructed facade of public declarations and into the labyrinthine corridors of digital whispers and alleged scientific leaks, a vastly more intricate and unsettling reality began to slowly but inexorably materialize. The seemingly perfect harmony of K2-18b's Hessian environment, its miraculously temperate climate, its vast, deep oceans and its burgeoning biosignatures started to evoke an unsettling sense of deliberate artifice, a narrative so exquisitely polished it felt unnervingly preordained. This intellectual odyssey through the shadowy claims and suppressed data has compelled us to confront a stark and deeply troubling divergence. The K2-18b presented to an eager world, and the K2-18b that, according to these unsettling alternative analyses, might truly reside in the distant reaches of Leo. If the official story tenders a comforting glimpse of emergent biology, a natural, pristine cradle of alien life, then the persistent undercurrents of dissent and leaked insights suggest something far grander, far more ancient, or tragically, far more terrifying. What if the anomalous data points, the unexplained light variations that defy planetary mechanics, the subtly discordant spectral readings that evade natural explanation, the persistent gravitational distortions are not mere instrumental noise, but the indelible, engineered imprints of deliberate design? The techno-signature hypothesis, compellingly hinted at by certain hushed analyses, posits a K2-18b not merely alive, but intelligently managed, perhaps even fabricated. Envision a biosphere meticulously cultivated on a planetary scale, its atmospheric chemistry, including that conspicuously abundant dimethyl sulfide, expertly optimized for some profound as yet unknown purpose. This would cease to be the chaotic organic breath of a wild evolving nature. It would be the controlled, purposeful exhalation of a vast integrated engineered system, a monumental testament to an intelligence that has long transcended mere adaptation to its environment, choosing instead to actively, fundamentally, and perhaps irreversibly sculpt its very world to its will. The very idea of colossal ancient artificial structures lurking silently beneath K2-18b's perpetually opaque hydrogen veil propels this speculative vision into realms of cosmic science fiction. The purported gravitational distortions hinting at immense, non-uniform mass distributions. The alleged hints of geometrically precise, almost mathematical surface features that utterly defy the fractal chaos of natural geology. The subtle, rhythmic changes in starlight, too regular for mere planetary dynamics. These are not the innocuous signs of an untouched primordial wilderness. They are the potential echoes of colossal construction projects, of sprawling sub-oceanic cities or orbital mega-engineering projects of unimaginable scale. Silent monuments to a civilization capable of wielding planetary forces, shaping its entire world as a sculptor shapes clay. Such a revelation would not simply end our cherished cosmic loneliness. It would irrevocably shatter our deeply ingrained cosmic hubris, forcing humanity to confront and acknowledge a species perhaps billions of years our elder, a master architect of worlds whose creations dwarf our most ambitious engineering dreams into mere child's play. K2-18b would then irrevocably transform from a fascinating distant planet into a monumental artifact, a silent enigmatic testament to an intelligence that has either long since passed into cosmic history, leaving behind only its titanic works, or perhaps still watches from within its shielded domain, its intentions utterly unknown. But the most chilling possibility, the one that might genuinely compel powerful institutions to meticulously maintain such an elaborate and pervasive veil of secrecy, is the stark spectre of a profound biological threat. What if K2-18b is not an idyllic Eden to be explored with scientific curiosity, but a cosmic quarantine zone to be avoided at all costs, its very existence an active danger? Imagine a form of life, evolved under such profoundly alien pressures and chemistries, a hydrogen-rich, high-pressure, solvated ocean world, that its fundamental biochemistry operates on principles not just different, but actively antithetical and virulently incompatible with terrestrial biology. The sheer abundance of dimethyl sulfide in this horrifying context could be reinterpreted not as a welcoming sign of life, but as a planet-wide warning, a potent chemical defense mechanism, or even the atmospheric signature of a superorganism whose very existence poses an existential, unquantifiable risk to anything that dares to approach from without. A mission to such a world would, therefore, transcend a mere act of scientific discovery. It would become an act of profound, irreversible folly, potentially unleashing an unknown, hyper-virulent pathogen or an aggressive biological entity that could devastate our own fragile, unprepared biosphere. The conspicuous absence of any serious, publicly acknowledged mission planning, therefore, transforms from a sign of scientific neglect into a grim, unyielding planetary-scale defense protocol, an interstellar containment strategy. These alleged hidden truths, whether they point to the silent remnants of ancient architects, the active presence of alien engineers, or the looming shadow of a menacing alien biosphere, radically, irrevocably reframe humanity's perceived place in the vast, indifferent cosmos. We began our centuries-long search for extraterrestrial life with an almost naive hope of finding a comforting mirror, a reflection of ourselves in the stellar depths. Instead, K2-18b, through these alleged suppressed insights, might offer us a profoundly distorted, unsettling image, a fundamental challenge to the very bedrock of our scientific frameworks, a harrowing test of our societal resilience in the face of the truly alien, and a profound, perhaps painful, questioning of our cosmic innocence. The facile comfort of 99.7% certainty regarding a benign biosignature gives way to the gnawing existential uncertainty of what are they truly hiding from us, and why? The core question then undergoes a profound transformation, shifting from a simple scientific inquiry of what is out there to a far more complex and politically charged interrogation of why we are being permitted to hear only a carefully edited fraction of the complete story. Is this a benevolent, almost paternalistic protection, shielding us from truths deemed too vast, too dangerous, or too disruptive for humanity to yet safely comprehend? Or is it a meticulously orchestrated, calculated maneuver to maintain fragile geopolitical stability, to retain absolute control over potentially world-altering knowledge, to prevent global panic and societal breakdown at any conceivable cost? The intricate control of the K2-18b narrative, if these leaks are indeed credible, lays bare the complex and often uncomfortable interplay between the relentless pursuit of scientific discovery, the immutable forces of political power, and the profound, often unpredictable psychological impact of humanity's first true, undeniable encounter with the truly alien. Agencies like NASA and their global counterparts thus assume a dual role, not merely as intrepid explorers of the cosmic frontier, but as solemn custodians of a cosmic secret, perpetually balancing the public's inherent right to know against the perceived, urgent imperative of planetary security and societal cohesion. This intellectual journey through K2-18b's dual competing narratives, the officially sanctioned public Eden versus the terrifying, whispered danger, underscores a fundamental, enduring dilemma of cosmic exploration. Every new, breathtaking data point transmitted by the James Webb Space Telescope inevitably pushes the very boundaries of our scientific understanding, simultaneously illuminating the vast, humbling gaps that remain in our collective knowledge. We, as a species, incessantly project our deepest hopes and most primal fears onto these distant, silent worlds, yearning for confirmation of our unique cosmic significance, or seeking profound solace in the notion of shared existence. But K2-18b, in its profound, almost defiant enigmatic silence, may be subtly, yet irrevocably, forcing us to mature as a civilization, to look far beyond the deceptive allure of simple, comforting answers, and to courageously embrace the profound, sometimes terrifying, complexity of a universe demonstrably stranger, more unpredictable, and ultimately more awe-inspiring than we ever dared to consciously imagine. The New Eden might, in the end, prove to be nothing more than a beautiful illusion, a necessary, carefully constructed myth designed to shepherd humanity through a difficult transition. The deeper, unvarnished truth, however, remains a cosmic enigma, a colossal puzzle whose scattered pieces, spanning 120 light-years of interstellar vastness, are slowly, painstakingly being reassembled by those few courageous souls willing to peer beyond the official reports, to question the accepted truths, and to challenge the very gatekeepers of cosmic knowledge. K2-18b is not merely a distant exoplanet, it is a profound catalyst for collective introspection, an immense, silent mirror reflecting not just the bewildering diversity of alien life, but also our own inherent fears, our own boundless aspirations, and our own profound, sometimes unsettling capacity for both breathtaking awe and calculated deception. It stands, therefore, as a silent sentinel, beckoning us to understand not merely what exists far away in the stellar dark, but what we, as a species, are truly prepared to face within ourselves when the ultimate cosmic truth finally undeniably reveals itself. We may, tragically, never fully pierce the dense intentional veil of secrecy surrounding K2-18b without the advent of unprecedented unfiltered data or a profound shift in global transparency. But the mere tantalizing possibility of technosignatures, of artificial structures of titanic scale, or of a forbidden biological threat, irrevocably alters our cosmic perspective. It transforms the seemingly benign search for extraterrestrial life from a purely academic scientific quest into a profound, immediate, and inescapable existential challenge. The universe, we realize, is not just vast and silently indifferent. It is pregnant with hidden narratives, teeming with possibilities that utterly defy our neat, comforting categorizations. K2-18b, whether it ultimately proves to be a genuine Eden or a cleverly disguised potent warning, has already changed everything. Our centuries-old cosmic loneliness may indeed be drawing to a close, but it might be replaced by a chilling cosmic apprehension, a profound, unsettling realization that some truths are simply too monumental to be fully contained, too disruptive to be publicly acknowledged, and ultimately, far too dangerous to be ignored. The whispers of K2-18b will continue to resonate, a timeless testament to the universe's inexhaustible capacity for staggering mystery and humanity's unending, often uncomfortable, yet utterly essential quest for the unvarnished truth.